Um, so a little bit, I'm here for these guys. So they paid for my trip here, so I have to talk about them. So I work for a company called OpsMX. That's VC funded. We have offices worldwide. We have people from Netflix, AWS. I myself have spent time at Oracle and Cisco over a decade. And we work with Spinnaker, okay? So, we have a booth out there, so you guys can always come by and talk about it. What I'm going to talk about is, I'll talk about the architecture of Spinnaker. I'm going to talk about the different install options that are available, and I'll do a very simple install in Kubernetes. Like, during this session itself, I'll set one up in Google Cloud, in GKE, and up and running and run a pipeline in it, right? So if you guys want to sort of try it out later, you can sort of do that. It doesn't take a whole lot. Then I'll talk about the different configurations that you can do in Spinnaker. And given how much time's left, I'll get into how you secure Spinnaker or any other production considerations when you actually have to take Spinnaker to production, okay? You guys are all here, so I'm not going to talk about what Spinnaker is. You guys already know it's a Spinnaker-only summit. But what I'm going to talk about a little bit is where I see Spinnaker being different or the value it provides as a continuous delivery platform. So where Spinnaker helps is, like, you can manage multiple clouds. Enterprises already have VMs. They're using AWS, Azure, on-prem. And then, there's a huge adoption of Kubernetes going on. So what Spinnaker allows you to do is manage multiple cloud environments from one platform. I think that's a big value. And it provides a single pane from where you can see what's going on, what resources are deployed, and you can even control and view them. What I like a lot is that, hey, if something's been triggered in Jenkins, or I want to see what this AWS resource looks like, or a Kubernetes resource looks like, I don't need to log into different UIs. I can view them right from that UI. So, it's a single pane of control, not only for the ops, but even the developers also, right? So that's a good thing. And another thing, it's a very pluggable model. You can customize it and plug in, enterprise rules and policies in there. So that's, again, a big plus I see for Spinnaker in terms of a continuous delivery platform. What does the Spinnaker architecture looks like? It's a microservices-based architecture, a lot of components out there. I'll briefly talk about them in here. There is the UI that you see is served by this deck, and everything is interfaced with Gate, which is like an API server, right? That you can have even APIs calling that Gate, and you can do automations with that. There are other components in there. The main one is the Orca, which is the real orchestration engine. That does the real orchestration, all the pipelines that you have, what should run next, and all that. That orchestration is done by the Orca, which talks with a bunch of different services. One of them is Roscoe, which is sort of called the bakery. That's where you build your images, like AMIs, machine, or Azure VMs, and all that. That's basically baked in Roscoe. Cloud Driver actually creates the resources for you, your VMs, your load balancers, your firewall rules. Whichever, are you using Kubernetes or AWS or Azure, it basically goes through Cloud Driver to create those resources. Fiat here is your authorization server. It basically controls the permissions. Do you have permission to do a task and all that? That is very basically powerful. It's group or role-based. So if you have a role, it will let you do it. If you don't have the role, you can't do it. So making sure that anyone cannot come in and just deploy to a production system, right? The other things in there are Echo it sends out emails, Slack messages, and all that. Igor allows you to monitor external systems and trigger pipelines. Like if you have an event in Git or a Docker image is built, you want to kick off a pipeline, that's where Igor comes into play and does that. And Kayenta is the inbuilt canary analysis there. How many of you are aware of canary analysis? Okay, quite a few. So what you basically do is that you have a software going out. You don't know how good it is. So what you do is you deploy your baseline, and then you deploy your canary out of your new release, right? What kind of does it? It basically looks at matrix from both these two releases and compares it and sees if it's good enough or not. And then if it's good enough, then you can make the decision to go forward and deploy to production, stage, all that. And finally, you have this Halyard. That's the configuration engine for Spinnaker. So Halyard sits outside of all of these. That's where you configure all your Spinnaker stuff, and that's what I will basically go through, the different configuration things that you can do. And then once you have set them up, you basically apply them to your environment. And then Halyard would spin up and down the nodes of a Spinnaker as required. Okay? So that's the microservices-based architecture for Spinnaker. If I have to install it, what are my options? Because it's a microservices-based architecture, the best install option is really deploying in a Kubernetes environment. Okay? You get the scalability that you can do very easily, as opposed to if you are doing sort of a local or a VM-based installation. It is provided, if you see the second bullet there. There are Debian packages available, and you can use them to deploy in single machines. I know people have done it on multiple machines. It's not fun or easy, but you can do it. But the easiest way to really manage a production deployment is in Kubernetes. The Spinnaker community does publish Ubuntu-based images. There's some Red Hat-based images that's published by OpsMX, certified by RHEL too. There is a Helm chart available to deploy it. That's what I'm going to use and set up a Spinnaker instance. And there are even operators available to deploy it in OpenShift type environments or even regular Kubernetes environments. So how do you install it? To install in Kubernetes, you need a Kubernetes cluster with at least 2 gigs of memory and 6 cores. You need Helm installed in your Kubernetes cluster. And it's better you have support for persistent storage. You can bring it up. I will show it to you without persistent storage. But if one of your pods goes down, you will lose data, right? So that's the drawback of not using persistent storage. But you should use persistent storage.
2 gig or 20 gig?
20. I'll walk through the values.yaml. How many of you are familiar with Helm charts? Right? So you guys know values.yaml is a pretty good way to configure your deployment. So there is a values.yaml that you can customize quite a lot, and I'll walk you through a little bit. So the Spinnaker Helm chart is published as part of the stable releases. So let's go off and install one. Is this visible at the bottom? No? Someone's saying here, but OK, I'll make it a little bigger. So what you can see here is I have a cluster already set up that has 6 CPUs and 22 gigs of memory available. It's running in Google. It's a GKE, Google Managed Kubernetes cluster. So what I'm going to do is run the command that I showed you earlier, right? Let me make this bigger so that more of you can see it. And let me, it will stay at the bottom. Can you guys see at the bottom of the screen? OK, good. So I'm going to do a Helm install. Just give it a name. I say that stable Spinnaker. And I have a values.yaml here. That would trigger up the installation of Kubernetes-based Spinnaker. It will take about 6 odd minutes. So let's go back and look at other things, and I'll come back and complete it over here. So when you are setting up Spinnaker, what are the different things that you configure? One is storage, right? What are the things that Kubernetes stores? It stores, like, you will create accounts in Kubernetes. Different providers you will set up in Kubernetes. All that information is persisted. As the pipelines run, the pipeline states are also persistent. Also, what Spinnaker does, it will go and discover all the resources that are there in the accounts out there, right? It will go to AWS, figure out all the resources that are running there, or Kubernetes resources running there. So that also is cached and available. So that's what storage is used for. I'll get into a little bit of what are the different types of storages are supported. Then there are these providers. Providers are the different cloud or providers that you integrate with: AWS, Kubernetes, Azure. So those are the things that you configure into your system, right, with credentials, so that it knows how to talk to it, connect to it, and all that. And that's where also you do is, in the same Kubernetes, you may register with different credentials, so that stage has a different credentials versus a production environment, so that you can control who gets to deploy where. You can also integrate with a bunch of CI systems, Jenkins, and all that. And then also you configure artifacts. And then you also configure pipeline triggers in there. Let's go look at how do I actually configure it. I talked about we use HAL. The Halyard, the box I showed on the right-hand side, you actually log in there and you run different HAL config commands, right? And at the end of it, once you're done, you do a HAL deploy apply. What it will do is all the configuration changes you did, it will take it, bunch them up, and apply it to that whole deployment. It will take care of stopping and starting the servers it needed. It's pretty intelligent in that if you made a config change that only requires restart of the cloud driver, it will only restart cloud driver, not necessarily the whole infrastructure, okay? Now, something's been added. I don't know if you were there at the keynote yesterday evening. It was talked about these dynamic accounts are being added. It's there for Kubernetes and Cloud Foundry, where you don't need to really do an HAL config and then HAL deploy apply. But what would happen is that if you can store your credentials and all these informations in either GitHub or Vault, and as you change them, they're automatically picked up by the system, right? Very useful where you have changing credentials. Now, it's not fully supported across all the providers, but it will be. Especially, I think, people where they have your credentials rotating very quickly, or not quickly. Every month you have to rotate your credentials. It helps in those cases where you push them out. Let's look at the different providers or different things that are there. Storage providers, what's supported? It supports Google, all the cloud storages. Google Cloud, AWS S3, Azure Storage. Also, it supports is like, hey, I don't want to do it, I want to try it. In fact, the one that I'm setting up right now is actually going to use a Minio setup to configure it. It does use Redis. Redis is used for caching. Like I talked about it, Cloud Drivers goes and gets configuration information, and it caches them. It uses Redis to cache it. It's been seen, especially when you have large amounts of accounts and all that, when you grow, performance of, say, any of the storage or Minio or Redis can affect the performance of your cluster. It may take longer, and it is seen that MySQL or basically a SQL provider would give you better performance. So there are integrations available for different components to use MySQL.
When you say large amount of accounts, what's your definition of large?
100 plus accounts. And how do you configure it? You can always configure later. Like if you have set it up with, say, like Minio, and I want to change it to AWS S3. I could always make that change later. But like, I will show to you that you can also configure it when you're bringing up Spinnaker. Like the Minio configuration that is there is pretty much like this. There is a Minio running on an IP, and then I give it an access key and a secret key and an access key, and then it will connect to the Minio and work. Now, if you're moving from, say, Minio to S3, something to keep in mind is that it will not migrate the data over. So before you do that, you make sure you back up your existing data, and then you change it, and then you basically restore your data back. So it provides capabilities for backup and restore. That way you can move it. And in fact, that backup restore is a good way to back up your configuration, right? If you're running it in production, you don't want to lose your data and all that. You want to keep backing them up. So you could do that. Moving on to the cloud providers. The major ones are the Google Cloud, Azure, AKS, AWS with its EC2, as well as the containers, ECS. Obviously, Kubernetes is a big part of this Spinnaker, and it also supports things like Cloud Foundry, Oracle. How you configure them? There are these bunch of HAL config provider commands. You can add new accounts there. I'm not giving out all the commands there, but just a reference that you go ahead and use HAL config type commands to configure these providers. What are the CIs supported? Things like Jenkins, Travis CI, Google Cloud Build, Concurs, Wrecker, and you use HAL config CI to configure these things. Okay. The other important aspect of Spinnaker is artifacts, right? What you're doing, you're deploying artifacts really. You're building an image, you're deploying that. You have a Docker, you're building a Docker image, you're deploying that. And you want to define that in there so that you can reference them, or making sure if they're not there, you fail. So any external resource that you reference is basically an artifact in Spinnaker. It's identified by a type, like a Docker image, GCS object, S3 object, or a Git repo, or a Kubernetes object. Those are the different types that are built in. You reference them via an URI to identify that object. And you also provide an account to access that object, right? And optionally, you can give it a name, version, metadata, location, provenance. What's the source of that object, right? You can use that as that. I will use it coming from this build. So you can use that source to identify where that artifact is coming from. It's used in a lot of places. Like, when you are building a pipeline, you can say expected artifacts, and you can define what artifact, you basically define the artifact that it's looking for. Or if you are running a job, like a Jenkins job, and it's producing an artifact, you define that artifact over there so that downstream processes, stages, can find and use those artifacts. One thing to keep in mind here, especially when you're defining expected artifacts, the two ways to run a pipeline. One is, it's triggered from some external resource, or you run them manually. If you plan to trigger them manually, it's always a good idea to define a default artifact, okay? It basically will look for that default artifact, because when you manually trigger it, there is no expected artifact being fed to it. So make sure if you plan to run it manually, define this default artifact. What are the different artifact providers? Lots of them. It can come from GitHub, Bitbucket, it could be a Helm chart, a GitLab, it can come from Maven, Docker, Google Cloud, it could be an HTTP resource, it could be an S3 resource. So lots of providers available for artifacts. And how you configure them? Using the HAL config artifact command. Any questions? Okay.
Can you talk a little bit about configuring all of this using Helm chart values YAML versus Helyard? Because I would assume if you want to reproduce your configuration, you want only one way to configure things.
Sure. I will walk through my Helm values.yaml where I do configure something, so that will give you an example of how it's done. Let's go back and look at how our deployment is doing. So it's basically this finished. It's telling me some things that, hey, I need to create some, it deployed basically, completed. I need to create some port forwards to access the URL, which is very nice if it's running on a local machine. And then I can access it using the local host. But if you want to set it up like in GKE, and you can see I'm using the Google Cloud Shell over there to access it, this port forward is not going to work for me, right? Or also if I set it up and I want to make it available for others, I want to make some sort of a service available. So what I'm going to do here is just create a Kubernetes service to expose this 9,000 ports so that I can get to it. kubectl expose. Oh, let me see what that port is. So you can see, a bunch of this. If you can remember the architecture diagram I showed, the DEC, Echo, Gate, Igor, all these are all running. Which one should I expose? You can remember which one exposes the UI? DEC, exactly. So you guys are paying attention, awake on a Saturday morning. That was a quiz. kubectl expose pod. Let me grab my DEC pod. The port I'm going to expose is 9,000. I'm going to make it a load balancer. And I'll give the pod name. OK, it's coming up. Let's monitor that as soon as we get a IP address, we can start using it. So ctl cat service. OK, it's still pending an IP address. So like I promised earlier, we'll look at the values.yaml I used. While we wait for the editor to come up. This doesn't take this long to come up. I'll probably just go ahead and show you the using regular VI. Not very visible, is it? Why are you taking this long to come up? There you go. In the cloud, if it doesn't work first time, you retry, it works. This one of my bosses told me is that when you are building something in the cloud, always plan for errors. Errors will happen. You cannot expect a perfect situation. So always code for errors. So this is a values.yaml file we are looking at. What you can control there is the version of Spinnaker you want to install. You can control the Helyard tag, Helyard image that you want to use to set it up. You can have additional scripts, like the question you are asking, how can I, in my Helm chart, configure different things that I want to do it? This is basically, you can put all your configs in here. Here I have a command that's creating a Kubernetes account in the Halyard. So this is the HAL command, config provider. Remember we had that, how you configure providers. Config provider, the type Kubernetes. It's an account, add, I'm giving it a name. What are the Docker registries it has, giving it a context. I'm telling it's a service account. So this is what the Kubernetes-based Helm does, is that you can either provide it a config file if you have available, or Halyard is already running in a Kubernetes. And if you want to use that Kubernetes, you basically say, use the service account that the Halyard is using, and so it will configure that account to use that service account so you can deploy to that same Kubernetes. Otherwise, you have to give it a kubeconfig file to talk to the Kubernetes instance.
Typically, would you have it separate, like run Spinnaker in a different cluster than you wanted to?
Typically, you would, especially in production, you would have your stage Kubernetes different, production Kubernetes different, and you would have Spinnaker running in another Kubernetes, which is different. There are customers we have seen, they have even an air gap. So they basically have two Spinnakers, one for stage, one for production. They don't even want the same Spinnaker to talk to both stage and production. So it again depends on your organization's needs and capabilities, or not capabilities, organization needs.
Mostly use the kubeconfig technique?
Yes, there you have to use the kubeconfig technique. Yeah, it's only when you want to deploy it to the same Kubernetes instance where Spinnaker is running, you can use this service account thing. And then I'm also telling it, it's restricted to a namespace. You can omit namespaces or restrict it to given namespaces. And I'm saying is that, remember when I was talking about cloud providers, that it will go look at and discover resources running within that? It will discover everything unless you tell it to only discover Spinnaker managed items. It puts in labels in those resources that Spinnaker deploys, so then it will only pull in those resources. So you will not see anything that's deployed in that Kubernetes by others. It will only see things that's deployed by Kubernetes or Spinnaker only. Now, a good way to see what all options are available is always you can go till any level and say -- help, it will give you all the options. So these commands are pretty nice. So you can always say HAL config provider Kubernetes -- help. It will tell you all the options that are available at that time. Yes?
Do you know if there were any talks on converting all of this into operator pattern and creating CRPs instead of using
Not really. I haven't heard about that. There is a Spinnaker operator, which is not what he's saying. He's basically saying manage Spinnaker resources. That Spinnaker operator basically, it manages Spinnaker as a whole, and it will bring up and down Spinnaker. Or basically manage the Spinnaker, not objects within Spinnaker.
It sounds like this Kubernetes account could be a CRP.
Sure, sure. Again, we can talk later on, but again, Spinnaker is a multi-cloud provider, or it supports multiple clouds. So a lot of the patterns you will see there are sort of generalized to make sure it works across multiple cloud providers. So, when you configure, there are different configurations that you can do. Logging into the HAL machines, those you can provide here. Like here, I'm basically updating the health check endpoint for the gate component, right? I can do that here. Otherwise, what I would have to do is log into the Halyard pod, put this file in the location it's supposed to be, .hal config default service directory, and then HAL deploy. But by putting it here, Helm chart will make sure it puts it in there, and it will restart the pod. You can control the memory of the Halyard pod here, And you can also control the memory and CPU of each of the components over there. That's actually part of Spinnaker configuration, which you would put in as part of these data, which you will put in part of this additional service settings. That's where you will put it in. Here you can define all the Docker registries. These are a set of accounts that you can create upfront through the values.yaml file. This is the default kube config it puts in. If you don't want to use this Spinnaker as the default account, you could always have your kube config and point to that kube config, and it will do it. So by default, if you don't update this, it will use that local Spinnaker in which you have deployed local Kubernetes in which you have deployed Spinnaker and set it up. You can also enable ingress for gate. You can enable some features in Spinnaker. By default, these features are not enabled. Pipeline templates is actually a very important feature, especially for enterprises, or you want to roll it out to an organization. This is sort of creating templates that any of your developers can take and start creating pipelines rather than everyone trying to build their own pipelines. You can help them bootstrap and start creating their pipelines. And then finally, out of the box, you can configure to an external Redis or an external Minio or a GCS S3. You provide all those information right here. There was someone I was talking with earlier saying, hey, I'm putting in all the secrets in here. I don't like that. Yes, if you don't like that, you basically put them in Vault and make them Halyard access that. You don't need to put them in here. So that's sort of covering the values.yaml file. Looks like our load balancer is up. We have an IP address, so let's log in. So there is our Spinnaker, right? You notice one of the things that I had enabled was pipeline templates. If I hadn't done that, this tab will not be available here. So that's how I enabled that pipeline feature. How many of you have seen this UI before? That's quite a few. My goal was not to walk through this whole UI and explain it to them. Explain all the features. But what I'm going to do is create an application, create a pipeline, and deploy an Nginx in there, okay? So to start off, I'll create a pipeline application here, which I don't have any, so I'm going to create a new one. I give it a name. I have to give an owner's email address. I'll give something. If I know what repo I'm using, I can select all that, but not necessary. I'm not going to really pull down from any repo or anything. So I'm just going to create an application. So once an application is there, you know, all the servers in this application would show up here, load balancers and all that. Right now, there's nothing. It's a brand new application that I created. So I'm going to pipelines and create a new pipeline. I'll give it a name, my pipeline. So when you create a pipeline, what you can do is basically add different stages. It's basically you're building a workflow. And there are other options that you can also set here. When I was talking about artifacts, you remember I showed a screen with expected artifacts. So if you want it to use some artifacts in some external resource, you can configure them here. Like say you have something in a Docker registry that you want to for it to use, you can configure them here. I'm not going to add anything here, just walking through it. You can have automated triggers, like if something changes in a GitHub, I want this pipeline to run. Or if something changes in an Artifactory, I want this pipeline to run. They even have a cron job. You can have it run every hour or something like that. So you can have automated triggers to trigger your pipeline. You can even have parameters, like you build a you build a pipeline that you want multiple of your developers to use. A good thing is each developer has their own namespace. So you can make your namespace a parameter so that if developer A starts this pipeline, they provide their namespace, and so that whatever they're deploying is going to their namespace. So you can have all sorts of parameters. If you want to build a particular version or a particular branch, you can provide all those as parameters. With that, what I said is I wanted to deploy a Kubernetes Nginx server, right? So I'm going to add a new stage. There are different types of stages available. I can bake a manifest file. Basically, it takes a Helm file and gets it ready to be rendered. I can delete a manifest. I can disable it. But what I'm going to do right now is deploy a manifest. Here, I get to select what account I'm going to use to deploy this manifest. When I showed the values.yaml, I showed this account that I had created. That's what I'm going to select. If there are multiple accounts, all those would show up here. I can choose what to use. This is a good thing. If you don't have any namespace defined in your manifest file, it's good to provide an override namespace so that you don't have developers going ahead and deploying manifest to any end namespace. You want to control where it gets deployed, right? So if this is a pipeline that deploys to stage, you want to control where stage is. It's better to provide this override namespace so that some developer doesn't go and deploys it to a production namespace, right? So I always do that. And what I'm going to do is I'm going to paste the manifest right here. I have a sample Nginx file that creates a deployment and a service. I'll copy this in here, and I'm going to paste it in here. A few other things I'd like to point out is that we're not going to do, but you can have different deployment strategies, like red, green, red, black, Highlander, and all that to control how the traffic goes, especially in production environments, we want to do that. But we're not going to do that. But just wanted to call out that those are available out of the box in Spinnaker. You don't have to code anything for that, right?
Are there any validation tools used here for, like, you pasted a valid YAML, but if I had a invalid YAML?
No, it doesn't do the check. It will fail, basically, when you try to deploy.
You just depend on Kubernetes to fail.
Right, right. You can actually have conditional expressions to control when the stage gets executed. And you can even restrict it to different time frames when you want to execute it. Like, production deploys happens only on Saturdays and Sundays, 9 to 10 p.m. You can control those things here. With that, I'm going to save this, and I'm going to run this pipeline. This is saved. Oh, I did enable the trigger. I don't want to enable the trigger. Where did I enable the trigger? I did not, so all the telling me it's. Anyway, I'm going to manually execute this one. So I say start manual execution, and I'm going to run this, okay? So it started deploying this pipeline. While this is deploying, I have about 5 odd minutes, but no, this will take about 10, 12 seconds. So what I can do always is, at this point, I can go and see as it's executing what's going on. It finished, actually, within 18 seconds. So each stage would give you details of what happened. I can see what got deployed, and what got deployed, I can even look at the YAML for that. And I think this is interesting to note here is you saw the YAML that I deployed, didn't have much. Spinnaker added all these annotations and labels in there to track it better, okay? This helps it in doing rollbacks and all that. Using this, it will basically, like if you deploy the next version and doesn't look good and you want to roll back, it will use this information to roll it back. Remember, I showed that only cache resources that's managed by Spinnaker is by virtue of this label it puts in there. That's how it actually controls what's Spinnaker managed versus not managed. So it does add or embellish the manifest files to make sure it can manage it better. Let's go look at the actual deployment. So you can see here is that right now this has a deployment in there. You can see this deployment. You can take actions like scaling it, undo the rollout and all that. You can edit it, delete it. You can see this is the replica set for that. You can just delete it. There's only one of them here. And this is the load balancer fronting that service, right? And this is the load balancer IP address for that. And I click in there. I have an NGINX running in there, right? I want to scale it to 2. I can go in here. I can actually say scale it to 2. It will go through the process of scaling it out and bring up a new cluster. I have about 2 minutes. What I'm going to do is just briefly talk through some of the 2 other slides that I had. First one is securing Spinnaker. The one that I set up was non-SSL enabled. I was hitting it by HTTP. You can enable SSL for the front-end endpoints, gate and deck, and that you do through this HAL config security UI commands, okay? You can enable authentication. There was no authentication in my system. You enable authentication using HAL config security authentication. Supported methods are LDAP, OAuth, SAML, X502 certificates, 509 certificates. You can also have authorizations. You can have LDAP, Active Directory, Google Groups, GitHub Teams, all that. And using it, you can control applications, accounts, pipeline executions. Who can execute what, all that you can control through that. Getting into production considerations, we talked about a little bit of persistent storage. We talked about a little bit that, in places, MySQL would perform better than just using pure Redis. Using Kubernetes, you can do a horizontal scale out of the different services. And my recommendation is that the default Helm chart that we installed doesn't have memory and CPU limitation or limit set. It's not good. So if you want to do it, definitely set memory and CPU limits, right? Kubernetes would be able to manage it better for you. And if you're having issues with caching, you see your cache, the front 50 is using up a lot of memory. You can control how often cache is refreshed. When I say cache is refreshed, like Cloud Driver would go out and look at what all new resources have come up. It runs that every 30 seconds. You could reduce that to 1 minute, 5 minutes, depending on your needs. That would control how often cache is refreshed. Also, there are ways to delete old pipelines, right? Otherwise, it keeps everything in memory. So, if you don't need anything or more than 7 days of pipeline history and all that, you can clean up your old pipelines.
Does this also do for configurations?
No. Yeah. So this is really for runtime information, like things that it discovers and all that, right? What's next? This was like, primer type of a thing, 101 type session. There is another session, a part 2 of this, I believe in the same room at 11 o'clock, where our CTO, Gopi, will cover pipeline templates, pipeline codes, Spinnaker permissions, getting more into the detail of the different objects and the hierarchy and all that, how to do canary and rollback, automated analysis and performance. Okay, so he'll do it. And before I say thank you, let's see that we have 2 of these already created in NGINX, right? So with that one click of a button, we did it. With that, thank you for your time. And I can be reached at nirmalya@opsumx.io. We have a booth out there. If you have any questions or comments, I'll be around. Thank you very much.
So